All right, the fourth part of Unit 4 deals with these two additional shortcuts, angle side angle and angle angle side congruence. And so we're going to deal with that here, hopefully in a quick rundown of these secret shortcuts. So our goal is to use angle side angle and angle side shortcuts to prove that triangles are congruent. And in order to do that, let's understand first what these shortcuts are referring to. Basically, if we have two pairs of congruent angles between two triangles and a pair of congruent sides that is included between the pair of congruent angles in either triangle, then the triangles themselves are congruent. So two angles and the included side congruent to two angles and the included side in another triangle. Therefore, the triangles will be congruent. In this situation, which two triangles are going to be congruent? You'll notice that they all have congruent angles marked with double mark, congruent angles marked single, and they all have a congruent side. All right, the question is, which of these triangle pairs are congruent? It turns out that this angle, side, angle shortcut is the one we're going to use for the first and last triangle. Write the congruent statement, triangle DOG is congruent to, triangle, and then let's make the right statement here, X, Y, Z. So double angle, side, angle, D-O and then G, X, Y, and then Z. All right, so we want to make sure that we list the corresponding parts in the corresponding order. This angle is marked with a double hash. Side DO corresponds to side XY, and then O is marked once, Y is marked once, G is not marked, Z is not marked. All right, so we can make sure that we have that congruent statement written correctly. While the order here of the first triangle does not matter, what matters is that the second triangle corresponds to the first. All right, so we can write this like 6 different ways. I'm not going to write all those out right now. Proving triangles congruent. Take a look at this situation. Draw that picture to the best of your ability. And then let's mark the things in the picture that we know based off of this given information. Being able to read this given information and apply that to a picture that is relatively blank is extremely helpful in the proof process. So here we know that AE and BD are parallel. That's what this symbol means. Sometimes we just draw arrows on there. Sometimes we draw a filled in triangle, however you want to do that. AE is also congruent to BD. Just because segments are parallel does not mean that they're congruent. In this case, these parallel segments are also congruent. These congruent segments are also parallel, so it kind of works out nicely. The angles at E and D are congruent. All right, so we're going to mark those as well. If I want to use angle side angle, I already have a pair of angles, I already have a pair of sides, I need another pair of angles. So which angles do I need? Think about what we did in the last lesson, or the last half lesson, where we had to figure out what other information is required so that I can use side, 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 or side, angle, side. Here, I want to use angle, side, angle. So I should note that that means I need to know that this angle is congruent to that angle. All right, we'll worry about naming those angles here shortly, but do I believe that these angles are congruent, and why are they congruent? So if I want to have a pair of angles, a pair of sides, a pair of angles, then I need to show that the angle at A is congruent to this angle at B, angle DBC. So I will show that that's true because these are corresponding angles. All right, if we look here, we can see that these angles are in fact corresponding angles from the corresponding angles theorem in Unit 2. When we have parallel lines cut by a transversal, the corresponding angles are congruent to each other. And so this is a pair of corresponding angles. Being able to visualize that is helpful, but also simply knowing that we are talking about a pair of corresponding angles is important as well. All right, so parallel lines, congruent line segments, congruent angles, and then I'm going to show that this angle is congruent to that angle using the corresponding angles postulate. Angle E is congruent to angle D. Oh, by the way, I'm structuring this proof in the order of a pair of angles, a pair of sides, a pair of angles. That is not required, but sometimes it is helpful when you are writing out your proof that you make sure that you make all of the statements that you need to make. So I'm going to talk about a pair of angles first. Angle E is congruent to angle D, and that's given. Segment AE is congruent to segment BD, that's given. And now I want to talk about this pair of angles, but I can't say that they're congruent yet without first stating that these lines are parallel. So I state that those segments are parallel, which means that the corresponding angles are congruent by the corresponding angles theorem. Given parallel lines, the corresponding angles are congruent. You can write that out if you can't remember if this is a theorem or a postulate or what the actual name of that theorem is or the number for that matter. And that means that these triangles are congruent by angle side angle. You could shuffle the order here. Really, any of these can be in any order. This one has to come after that. So this could be step 1, step 2, step 3, step 4, step 1, step 2, step 3, step 4, etc., etc. You could shuffle these around a little bit, but once you make this statement about parallel lines, then immediately after you should make the statement that the corresponding angles are congruent. All right. If you have any questions on that, make a note of that to ask me about it in class. Theorem 4.7, angle side congruence. So this one I'm going to be very particular about, and I don't feel that the textbook does an adequate job of describing this relationship here. It's not just two pairs of angles and a side. It's a non-included side in one triangle and the corresponding non-included side in another. So for example, we have this angle. These angles are marked once, and they're congruent. These angles are marked twice, they're congruent. And then we have this side that is not included. It's not between x and y, it's not between u and v, but it is the next side that comes after and outside of this pair of angles. So notice how this one is 1, skip a side, 2, the next side. All right? 1, skip a side, 2, markings, the next side. If we had, not this, but if we had those marked congruent, this triangle pair would not be congruent because this non-included side does not correspond to this non-included side based on the way that the angles are labeled, all right? 1, 2, the next side, all right? So be aware of that when you are thinking about the corresponding non-included side. You may have to think through that before you just assume that you have angle side, all right? Now this theorem kind of comes from an extension of the angle side angle theorem along with the third angles theorem. If these angles are congruent, all right, these pairs of angles are congruent, then that means that the third angles are congruent to each other by the third angle's corollary. And so that means that we just have an angle side angle here, angle side angle. All right, so it's just kind of a shortcut. It keeps you from having to do an extra step or two. All right, so let's use angle side in this proof. Draw that picture to the best of your ability, and then let's label this information. Maybe pause the video if you want to try to put this information into that picture on your own. All right? Pause it if you want to, and see if you can write this proof out. I will go ahead and do this, though, if you don't want to pause it. PR, segment PR, that's this one right here, bisects angle SRQ. Angle SRQ is this big angle here. And we're going to cut that angle in half, which means that this part and that part are congruent to each other. That's what bisect means, by the definition of bisect. Angle S is congruent to angle Q, that's given. And in order to finish this proof, I need to have a pair of sides. Well, I can't show that these sides are congruent. There's nothing in the picture that's going to tell me that SP and QP are congruent. There's nothing else given there. All right, so I have to use reflexive POC to say that RP is congruent to RP. So that's what I'm going to do, and then I have a pair of angles marked once, a pair of angles marked twice, and a pair of sides. All right, that I can mark once or twice, doesn't matter. All right, so first I'm going to say angle S and Q are congruent, given. PR bisects angle SRQ, that's given information. But I'm going to use the definition of bisect. We're bisecting an angle. So when it says that PR bisects the angle, it doesn't mean that these sides of the angle are congruent. It means that the angle parts are congruent to each other. We cut the angle in half. We're not talking about the sides, we're talking about the measure of the angle itself that is cut in half. So if this was 100 degrees, now each of these are 50. If this was 120, each of these are 60. If this was 180, well, it's not, then each of those would be 90, all right? So we kind of be able to cut that in half. So PR bisects that angle, which means the angle is now cut into two congruent angles. So angle SRP, let's trace it out, SRP is this part right here, is congruent to angle QRP. QRP is this part. By the definition of bisect. Whenever you're told that something bisects, you know in the proof you're going to use the definition of bisect. Here we bisected an angle. Subject, verb, direct object, this is what's been bisected, the angle, which means we have congruent angles. If you bisect a segment, you're going to have congruent segments. If you bisect an angle, you've got congruent angles. Either way, you're going to use the definition of bisect in your proof. PR and PR are congruent, or RP, RP, however you want to say that. Reflexive POC. pair of angles, pair of angles, pair of sides. You've got an angle, angle, side, triangle congruence. You can just copy this from here, all right? So you don't have to worry about which order did the letters go, because it's already given to you. It's already stated for you, so you don't have to think through that. Again, restating the given, copying this gets you 2.5 of the 5, points here, or the 5 steps. And so that's really helpful. Here's a freebie. Definition is supposed to be a freebie. And then, of course, understanding that you're using angle, angle, side. Obviously, I gave you that heads up, but being able to recognize that on your own is kind of the goal here. All right, take a look at these items and see if you can think through why each of these are going to be congruent for those reasons, and maybe why these items are not congruent. All right, I want you to think through that. If you believe, and copy these pictures down, all right? Angle, side, angle, pair of angles, pair of sides, pair of angles. Angle, angle, side, pair of angles, corresponding non-included side. All 3 sides. Here we have a side angle side. Here we have 2 pairs of sides, but the angle is not included between the sides, so that is a little dodgy there. We need to make sure that we're doing a good job there, that we cannot say that those are congruent just because they have 3 parts congruent. It's not the right 3 in the right order. All right, to finish this out, you are going to do this proof. All right, I have given you some reasons. I've talked about what bisect means in a previous statement. We have a subject, verb, direct object, so we know what's being bisected. I think, and I'm confident that you can do this proof. Keep in mind, you've got parallel lines, which means that you have some special angle relationship there. Use the vocabulary from Unit 2, given, etc., etc. All right? There's some freebies in there. Utilize those freebies, and then tell me if you're going to use side, angle, side, 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 angle, or angle, angle, side shortcut. You do that proof. And then when you're done, you should be able to say yes, that you can use angle, and angle, side shortcuts to prove these triangles congruent. All right? Have at it. Do a good job. See me for help or if you have questions.